Good morning, students. So today we are going into the third derivation of this module, that is minimum teeth required on pinion or gear in order to avoid interference. So before going into that, we should know what is an interference is. From the name it is suggesting that interference means one person interfering in others' life. Like that we'll use to tell. So you are involving in an other's space. Similarly here also, when two teeth on the gears, for example, you have a pinion, you have a gear, both are meshing each other. When they come closer, one teeth comes over the another. So when it happens, there will be some undercut or extra wear and tear happening on the gears. So we need to design the gear in such a way that the interference is avoided. So minimum teeth should be this much, should be considered in order to avoid the interference between the teeth which is meshing with each other. So when we are going into that, first of all we'll draw the diagram in order to find out that. So the diagram will be similar to the previous diagram where we use for length of path of contact. So like this, the diagrams you can draw. Here you should mention what is R, what is capital R. RA and small RA and capital RA is not required here, only small r and capital R. Then the angle phi you should have. Then you should show the two teeth in contact. Then you should label all the different addendum circle, pitch circle, base circle. So all the different things you can show here. So after this we'll move on to the derivation part. So next we will move on to the derivation. So the derivation, it's about minimum teeth required on the pinion in order to avoid interference. So here we have to assume the values of small t. It is the number of teeth on pinion. Capital T will be, I always told you regarding this, like all the capital letters will be used for bigger wheel or bigger gear, that is wheel, and small letter will be used for pinion, that is a smaller gear. So small t will be teeth on pinion, capital T will be number of teeth on wheel, M will be the module of the teeth. Module of the teeth means that is a constant fixed value. For every teeth there will be this much value, 1 centimeter, 2 centimeter, like that. So that is a fixed value, that is module. Then R is the pitch circle, small r is the pitch circle radius of the pinion. It can be also written as one more formula is there for finding out the value of pitch circle radius, that is mt by 2, where m is the module, t is the number of teeth. If you have the module and number of teeth on pinion, you can find out the pitch circle radius, that is mt by 2. Now gear ratio is a constant again. Capital G is equal to capital T by small t, that is number of teeth on wheel by number of teeth on pinion, or it is also equal to the radius, pitch circle radius of wheel by pitch circle radius of the pinion. Phi is the pressure angle or the angle of obliquity. Now we can see, you have to first take this triangle in the figure O1NP. So in the triangle O1NP, what is O1N square? So here you are using the formula called as cosine formula. Cosine formula means if you want to find one side, here we are taking O1N. O1N if you want to take, so that square is equal to the square of the other two sides. O1P is one side and other side is Pn. The square of other two sides, that is O1P square plus Pn square minus 2 times the other two side O1P into Pn into cosine of angle between the other two sides. So that is the cosine formula. So we will apply the cosine formula directly here. Hope you understood this. So now what is O1P? O1P is nothing but the small r. And what is Pn? Pn we have already found out in the previous derivation, that is r sin phi. So I am not explaining again here. So Pn is r sin phi minus, so you will substitute everything directly, 2r into capital R sin phi into cos O1Pn. What is cos O1Pn? So if you want to find out that angle, so first we have to take the other triangle, smaller triangle below, that is O1MP. O1 MP, you have one 90 degree, another one is phi. So obviously the third angle will be 90 minus phi. Okay, so that we know by the construction geometry, we know the third angle that will be 90 minus phi. So if you want to find out the other angle on the other side, that is, you will consider it as a linear pair. So if you want to find out the angle O1PN, you know that O1PM is 90 minus phi. So obviously the other angle should be 90 plus phi. Then only both will be 180 since it is linear pair. So like that we will find out the value of cos O1PN as cos of 90 plus phi. Okay, now we'll move on to the next line, that is r square. The same thing, only the thing difference here is what is cos plus theta, it will be sin theta. So sin phi into sin phi will become sin square phi. Now in the next step we will take all r square common outside. So you will get the formula like that. Now what we'll take is, now we'll come down. So now O1n is equal to taking the square root on other side. R square will become r and root of 1 plus r by r into r by r plus 2 into sin square phi. Now here you will substitute r. R is nothing but mt by 2. So next is we need to find out the addendum. Addendum you need to find out. Addendum, hope you know that. Addendum is nothing but it is the radial distance from the pitch circle to the top outer addendum circle. Similarly, dedendum is the radial distance from pitch circle to bottom of the teeth. So addendum is nothing but AP into module, that is formula we will have. AP is, it is a constant, it is a fraction which will be added to the module in order to avoid interference. So that is the actual addendum, you can find out by substituting this value. And one more method, you can find out the value of addendum by subtracting the total addendum circle radius minus the pitch circle. So from the figure you can understand total radius of the addendum minus the pitch circle radius will give you the only the height, that means from the pitch circle to how much distance to the addendum circle. So that is the formula we are using here, O1n minus O1p. O1n is nothing but the addendum circle radius, O1p is the pitch circle radius. So we'll substitute AP into m is equal to O1n. O1n is mt by 2, this we are already found out above, minus O1p. O1p is nothing but the small r. Small r is the pitch circle radius, that is nothing but mt by 2. So we have substituted that. Now we'll take mt by 2 common outside from the equation. Now we can cancel m from both sides, AP into m and this mt. If you cancel, you will get AP is equal to t by 2 into root of 1 plus t by t into t by t plus 2 sin square phi minus 1. Now you will keep t on one side, take all the other thing on the other side, you will get a formula like this, t is equal to 2ap by 1 plus t by t. So in this formula, t by t we can substitute by g, because g is the gear ratio, that is capital T by t. So we'll get the final equation like this. So this is our required equation. So this is how we'll calculate the minimum teeth which is required. So this is very important when we are designing a gear. We should know how much number of teeth is minimum required in order to interference, in order to avoid interference. Otherwise interference will occur. So that is how we'll find out here. And here for if the number of teeth on both pinion as well as wheel is equal, the value of g will be 1. So the equation will get reduced into this, t is equal to 2ap by 1 plus 3 sin square phi minus 1. So this is a formula to find out the minimum teeth required on both gear as well as on pinion.